Hello students, welcome back to my YouTube channel. I am Shlok Kulkarni and today we are going to continue with our departure Oxford General Navigation numericals. So far we have done the first 8 numericals. Today we are going to do the next numericals. I hope you have understood the first 8 sums, how to do them, how to approach them, what is the concept behind every sum. Okay, so I suggest you all keep practicing those sums again and again, also without also practice those sum without taking any help from any explanation or solution, or without watching this video. See how much you can do it on your own. Be confident, have faith in yourself, believe in yourself, and keep practicing. You will get there. So now let's start with question 1 for today. So that is question number 9. So far we have done question number 8 up to question number 8. So now today's question is question number 9. So question number 9 is aircraft Q flying at a ground speed of 301 knots flies parallel of latitude 46° north through 10° of longitude. Aircraft R with a speed of 364 knots flies between the same meridians. So it flies between the same two meridians that aircraft Q is flying, and in the same time. Okay, and in the same time also. What is the latitude of the track of second aircraft, which is aircraft number R? So let's write the solution. Aircraft Q with the speed of, so speed is, so speed given to us is for aircraft Q 301 knot, and d long is given 10°. For aircraft R we have speed of 364 knot and d long is the same, which is 10°. Now time of this aircraft and time for aircraft R are also the same. Now we have speed, we have d long, we can calculate time because d long will give us distance, which is run line distance. So let's start. For aircraft Q, run line distance equals to d long in minutes into cos of latitude. Okay. So aircraft Q is at a latitude of 46° north. So d long, which is 10°, convert that into minutes, 60 into cos of latitude is 46. So cos 46, 600 into cos 46, 417 nautical mile, approximately 417 nautical mile. So this is the distance that aircraft Q covers between a d long of 10° longitude. Now we can easily calculate time for aircraft Q, which is this time is equal to distance divided by speed. Distance is 417 miles divided by speed. What is the speed given to us? 301 knots. So do it. 417 divided by 301 knots is 1 hour 23 minutes. 1 hour 23 minutes. Now the second aircraft, which is aircraft number R, it also takes same amount of time of 1 hour 23 minutes. 1 hour 23 minutes. Now we have to find the latitude for that aircraft. So we have speed, we have time. Okay, so we can easily calculate distance for aircraft R, which is equal to speed into time, which is equal to speed into time. So speed is 364 knot, time is 1 hour 23 minutes. time is 1 hour 23 minutes. So multiply both of them. 364 into 1 hour 23 minutes will be equal to 503.5 nautical mile. 503.5 nautical miles. So distance covered by aircraft R is 503.5 nautical mile at the speed of 364 knot. And the distance covered by aircraft Q at a slower speed of 301 knot was how much? 417 nautical miles. A little less than that. So let's use for aircraft R the Rumline formula. Using the Rumline formula, you will easily get latitude. So Rumline distance equals to d long into cos of latitude. So Rumline distance is how much? 503.5 nautical mile. Let's take it to be equal to 503 only. D long is same 10 degree. Convert that into minute 60 into cos of latitude. Into cos of latitude. Into cos of 503 into 10 into 60 into cos of latitude. So 503 divided by 600 is equal to cos of latitude. So 503 divided by 600 equals to 0.8 equals to cos latitude. So latitude is cos inverse 0.8. So in order to find cos inverse of any values, hit the top left button shift and then press the cos button. You will get cos inverse. So that is equal to latitude of 33 degree. That is equal to the latitude of 33 degree north. Okay, 33 degree north or 33 degree south. So this is the latitude at which aircraft R or aircraft Romeo is going to fly his aircraft, okay, or is flying his aircraft at. So we are at aircraft latitude 33 degree north or 33 degree south. So again a quick recap. We were given two aircraft and whatever information was given in the question, we wrote that information here. Now then we saw what data we have, and with that data what we can derive. So for aircraft 2 we had speed, we had d long, and we had to find time. Okay, so we know that d long comes in the formula of Rumline distance. So we employed Rumline distance, substituted the values. Cos of latitude 46 was given in the question. We calculated distance, we calculated time. Now with this time that is taken by aircraft Q is the same time that is taken by aircraft R. So we wrote that here. Now when we have speed and when we have time, it is easy to calculate distance using speed into time formula. So we got distance which is nothing but a Rumline distance since d long is given. D long is given in the question. So they are talking about Rumlines. So the Rumline distance we got 503 nautical mile. So we used again the Rumline formula, substituted the values and found latitude for aircraft R, which can be 33 degree north. So aircraft R can make that distance at 33 degree north or 33 degree south. It will be the same. So that is question number 9 for you. Let's go to question number 10. Aircraft S leaves position 36 degree north 10 degree east at 15:22 hours and flies a Rumline track of easterly at speed of 470 knots until it reaches 13 degree east meridian when it turns onto a track of 180 degree. So let's draw this diagram. Let's draw aircraft S. So I will take a new slide. So aircraft S leaves position 32 degree 36 knot 10 east. So we have aircraft position. Aircraft S leaves position 36 knot 10 east at 15:22 hours. 36 north 10 east. Flies a rumline track of 090. So this is a rumline track of 090 degree at a speed of 470 knot until it reaches 13 degree east meridian. 13 degree east meridian. 13 degree east meridian. When it turns onto a track of 180 degree at a speed of 460 knot. So after reaching 13 degree east meridian, which is this meridian, it turns southerly direction. Okay. So this is your starting point. From here aircraft flies 090 heading. Then it turns southerly direction. Let's write the speeds. Starting the speed was 470 knots. And the speed decreased by 10 knot and became 460 knot. 460 knot. Okay. Next. Aircraft T leaves position. So this is the information that we have been given about aircraft number S. Initial time was 15:22 and next time is not given. Now aircraft T leaves position 30 degree north 10 degree east. So 30 degree north 10 degree east at 15:22 hours. At same time there is another aircraft leaving from another latitude at 30 degree north but the same meridian. The meridian is the same. Meridian is the same, which is 10 degree east. And flies a rumline track of 090. It flies a rumline track of 090 at a speed of 150 knots. At a speed of 150 knots. Okay. At a speed of 150 knots. So all the information that was given in the question, we have put it in the form of diagram. So there is one aircraft which is starting at aircraft S and aircraft T. So aircraft S starting at 36 degree north at 15:22, going east, coming down at southerly heading, longitude 13 degree east. Same longitude but another latitude 30 degree north, we have another aircraft Tango which is starting at heading of 090, speed 150 knots. Now let's look at the question. Which aircraft reaches position 30 degree north and 13 degree east first? So question number 1 is, this aircraft starts at same time, this aircraft starts at same time. Out of these two aircraft, which of them, Sierra or Tango, will reach this longitude? This longitude that I am drawing will reach this longitude first. Will this aircraft reach this longitude here first, or will this aircraft reach this longitude here first? So now this is the, when you travel easterly direction like this, you are actually following a rumline track. So let's draw two columns, one for S, another for Tango aircraft. So now we have been given speeds for both aircraft. we can calculate distance. Okay, we can easily calculate distance because we have the longitude, initial longitude given to us, final longitude also given to us. So Ramline distance for Sierra is d long in minutes into cos of latitude. So d long is how much? In this case, d long is equal to 13 degree east and 10 degree east. So if locations are in the same hemisphere, that means we will have to subtract them to find d long. So 13 east, 10 east, subtraction will give you d long of 3 degree. So right here d long is 3 degree. Convert that into corresponding minutes. So multiply by 60 into cos of latitude. For Sierra, the latitude is 36 north. So cos 36. Over here, Ramline distance is equal to cos of latitude into d long in minutes. So cos of, now for aircraft Tango, the latitude was 30 degree north. So write 30. D long is the same, 3 degree into 60. So multiply 3 into 60 into cos 36 is how much? Using your calculator, 3 into 60 into cos 36 is approximately 146 nautical mile. Over here the distance is cos of 30 into 3 into 60, which is 156 nautical mile. So this is 146 nautical mile. This is 156 nautical miles. Now we have speeds for both aircraft. Aircraft Sierra is flying at a speed of 470 knots, and aircraft Tango is flying at a speed of 150 knots. Now when we have distance and when we have speed, we can easily calculate time. So time here is distance divided by speed, 146 divided by 470. Over here time will be 156 divided by 150. Okay, so in both cases time is how much? 146 divided by 470 is 18 minutes. Over here 156 divided by 150 is 1 hour 2 minutes. So clearly you can see which of these aircraft will reach position first. So which aircraft will reach position first? That is aircraft Sierra. Aircraft Sierra. So aircraft Sierra will reach position first because clearly the speed of aircraft Sierra is 470 knots and this speed is 150 knots. So aircraft with a faster speed will reach its destination longitude first. Let's go to question 2. Give the position of other aircraft at this time. So now at the end of 1 hour 2 minutes, so the second question is the continuation of the first question. So it says aircraft S reaches 13 degree east longitude at 18 minutes. Okay, so aircraft Tango will reach, the question says the aircraft Tango will reach what longitude at 18 minutes. So look at this diagram. So aircraft S will start from here and reach this longitude at 18 minutes. Okay, after 18 minutes. After 18 minutes, where will this aircraft Tango be? Will it be somewhere here? Will it be here? Will it be at this longitude? Which longitude will aircraft Tango will be at? So that we have to find out. So now again, so let's solve that sum. Speed is how much? Speed of that Tango aircraft is 150 knots. Time is what? 18 minutes, or we can convert that into hours by dividing 18 divided by 60. So that is 0 degree 18 minutes. Now distance is equal to how much? Speed into time. So 150 into 0 degree 18 minutes, 0 hour 18 minutes is equal to 45 nautical mile. So at the end of 18 minutes, this aircraft Tango will have covered how many nautical mile? 45 nautical mile. Okay, now let's use Rumline formula. Rumline distance is d long into cos of latitude. So 45 is equal to d long into cos of, what is latitude? Latitude of Tango is 30 degree north. So cos 30. So d long is equal to 45 divided by cos 30, which is equal to 52 minutes. 52 minutes. 0 hour 52 minutes. Okay. So now our initial longitude is what? Given to us 10 degree east. That means we are in the eastern hemisphere. When we are in the eastern hemisphere and we are following easterly heading, what will happen to our longitudes? Our longitudes will increase in value. So 10 east, 20 east, 30 east, 40 east, so on and so forth. So definitely a new longitude will be more than 10 degree eastern longitude. So initial longitude is 10 degree east. D long is 0 degree 52 minutes. Okay, 0 degree 52 minutes. So final longitude will be initial plus d long, which is equal to 10 degree plus 0 degree 52 minutes. So final longitude of the aircraft is 30 degree north, 10 degree 52 minutes east. 30 degree north, which is the same latitude, and 10 degree 52 minutes east. So that is the final longitude of your aircraft Tango at the end of 18 minutes. At the end of 18 minutes. So at the end of 18 minutes, the aircraft Sierra is at longitude 13 degree east. But aircraft Tango, the other aircraft, at the end of 18 minutes is at 10 degree longitude. So 3 degrees short of 13 degree longitude. Let's go to question number 3. At what time does this occur? At what time does this occur? So aircraft Tango starts his flight at what time? At 15:22, 15 hours 22 minutes. So he will reach this longitude at the end of 18 minutes that we calculated. So aircraft T will reach longitude 10 hours, 10 degree 52 minutes east at time, what time? So 15 hours 22 minutes plus 18 minutes. So that is equal to at the time of, use your scientific calculator, 15 hours 22 minutes plus 0 hours 18 minutes, 15 hours 40 minutes, 15 hours 40 minutes. Okay, so at 15 hours 40 minutes your aircraft S will reach final longitude, but aircraft T will reach longitude 10 degree 52 minutes east. So this is the sum. Whatever information was given to us, lot of data, very big data, but when you put that in the diagram, it becomes easy to visualize. So always do that. Start with the first statement and go on plotting or drawing whatever they have given in words. After that, solve every question one by one. Okay, over here everything is about drumline distance formula, speed distance time formula, using scientific calculator, and knowing the concept well. So simple maths. When you start doing all this, it is very easy. But when you look at the question, it appears very hard. But that is not the case. Okay. So with this question, we will stop here. So we will stop here. We will continue with our next questions in the next departure video lecture. So do be present in that video. I hope you have understood all these questions that we have done till now. We have done so far 10 questions from this chapter. Very important 10 questions. Nothing other than this can be asked in exam. Okay, different types of these questions can be asked, but the pattern, the format or the concept will remain the same. So keep practicing. Okay, keep practicing on your own. Set a timer. See that you are solving every sum under 2 minutes at least. Okay, because now over here when I teach you all, I teach in detail everything. But when you are doing every sum at exam, you can just do everything in rough work very fast and save lot of time, because you have to do 100 questions in 3 hours. That is possible, very possible to solve all questions in 3 hours, but you should have speed, and for that lot of practice with a timer set next to you. Okay, so that you can keep on perfecting yourself. So let's meet in the next video. Do hit the like button, subscribe to this channel to keep getting new and new notifications time to time, and share this video with everyone. Thank you for your time. All the best. Keep learning.